So for this first lesson here, we're going to take a look at this concept of identifying functions and what's a function. So we've looked at relationships before. A relationship or relation is just a connection between two variables. Relations are represented by either a set of ordered pairs. So here we have the set. Just note these little curly brackets here. All right, I'll make a little bigger one for you. The curly brackets kind of look like that. I believe on the computer they look a little more like a pointy bracket like that. We call them curly brackets. So the curly brackets, they represent a set of things. That set of things is these ordered pairs, the 0.01, the 0.12, the 0.23. Okay? So we can represent a relationship between two variables, generally x and y, by a set of ordered pairs. We could also use a table of values, or we often call it a t-chart, because it kind of looks like a t. So we have, the same values here. 0, when x is 0, y is 1. When x is 1, y is 2, so on and so forth. So that's another way of doing it. We could also plot these on a graph, and in this case, we plot them on the graph, 0, 1, 1, 2, 2, 3. Connect the dots, we get a line. So we got 3 different ways of representing this here. And then, get a little more advanced, we can jump in, we can use an equation where y equals x plus 1. And if we look here, 0 plus 1, 1 plus 1, 2 plus 1. There's our y values. They're just taking the x values and adding 1. Or, brand new, you've probably never seen this before, we can use a mapping diagram. And so a mapping diagram takes all our x values and puts them in one blob, and all our y values puts them in another blob. And then we take arrows and we draw arrows from each x value to the y values that it's equal to. So in this case, 0 is equal to 1, 1 is equal to 2, 2 is equal to 3 for the y. So there's the map that kind of shows the relationship between these. So let's talk a little bit more about mapping diagrams. So mapping diagrams, and I'm just going to move my keyboard out of the way here, make some room. Our mapping diagrams, they are a visual way of representing our relationships between different values. And we use arrows to map the x values to corresponding y values, as I mentioned. So here's an example. And we have some dogs, and some dogs like to chase things around, right? You may have had a dog or seen a dog chasing whatever object, animal, something. So here we got 3 dogs. We got Rex, Leroy, and Baxter. And they like to chase different things. Rex chases cars and cats. Leroy chases cats only. And Baxter, well, Baxter likes to chase squirrels. So if we illustrate the dog chase habits with a mapping diagram, we take our x values, our independent values, which are our dogs, and we have Rex, Leroy, and Baxter in the one blob there with x. And then in our y blob, we got the cars, cats, and squirrels, the different possible y values. So if we were now to take this and make a mapping diagram, we need to draw lines from each of the different x values to the y values that they represent. So Rex likes to chase cars. So we draw an arrow from Rex to cars. Rex also likes to chase cats. So we're going to draw an arrow from Rex to cats. Then Leroy, well, he likes to just chase cats. So we draw an arrow from Leroy pointing to cats. And finally, Baxter likes to chase squirrels. So Baxter goes down here, and there we have Baxter chasing squirrels. That's what it is to do a mapping diagram. You take all the x values and then any y values that they will represent. So in this case, Rex has 2 lines, where Leroy has the 1 y value and Baxter has the 1 y value to represent. So that's a mapping diagram. It's just another way of looking at some of these relationships. we find they're sometimes useful when we're trying to visually see the relationship between a large set of data, and this kind of helps us out. A lot of times you've probably been experiencing just having the situation where, you know, each x value has a single y value, but that is, like this case here, each one of these linear x values has a single y value, but that's not always the case. There's different situations that happen when we start looking at math in the real world where different values connect together. So now if we continue on, we're going to make a mapping diagram for the following table of values. So we got a values here, 1, 2, 2, 3, 4, 5, 1, 4, 3, 7, 6, 10. So we want to list out all the different x values and all the different y values. So I'm going to go through, list the different x values. I got a 1, a 2. I'm going to do them in order. You don't have, there's no requirement for order or anything in the mapping diagram. I'm going to do them in order just because that makes sense to me. So 3, there's a 4 and a 6. And then I'm going to put those in a blob x. And then my y values, I got slightly out of order here, so I'm just going to rewrite those in order. I got a 2, a 3, a 5, a 4. Let's do them in order. Again, order doesn't matter. I'm a fan of that. It might be my mathematical thinking. So here's my second blob. So now what I want to do is I want to connect the dots, connect the lines kind of thing, and make a map from the x values to the y values. So I'm going to go through the table. 1 and 2. So when x is 1, y is 2. There's 1. 2 and 3. 4 and 5. 1 and 4. Ooh. Okay, so now I got to kind of draw this like this. There we go. So we got that 1's pointing at 2 different values now. 3 and 7. A little crisscross here. And 6 and 10. So there's my mapping diagram. Now, you're going to encounter 2 different types of scenarios. One where the x values might, each individual x values hit multiple y values, or each x value hits one y value. And so now these will cause different issues. And so now we need to talk about the second half. And so going back to the start here, this concept of relation, that is half the name of this course. It's functions and relations. So let's talk about the relation half of it. We've talked about the relation half of this course. Let's talk about the functions. So what's a function? So a function is just a relation where every x value maps to a single y value. So if you have any given x value, it's going to go and provide you with a single matching y value. What's that look like? Let's take a look. We have kind of this, sometimes we use this function machine to show that. If you have a machine, you're running a factory and you're manufacturing products, if you put something into the machine, you want to know what it's going to put out. If it's going to put random things out every time you put a round lump of yellow Play-Doh in, it gives you something completely different. One time it gives you a yellow cat, one time it gives you a yellow dog, one time it gives you a yellow bird. That might not be good in terms of manufacturing things. You want to put in a yellow lump of Play-Doh, and every time you want that yellow lump of Play-Doh to make a cat. You want to have little Play-Doh cats pumping out of your machine so that you can sell them on eBay for millions of dollars because they're fancy, cool cats. So a function, that's what it requires, is that it does the same thing every time. Thus, anything you put into the machine, your input, which is your x value in general, is going to create a single output, generally your y value. So the y value is what's coming out from the x value that you're inserting into the machine. When we talk about functions mathematically, we use the notation f at x. I use a fancy little f. Most of the time you'll see this kind of fancy kind of cursive scripted f. Not really cursive, but more scripted f. It's perfectly fine to just put a simple f at x. I just do it to note, just like my x's, I kind of have like the kind of fancier, funkier x, just to separate it from a time sign, things like that, and the letter f. So I use this kind of curly, funky f. Whatever you want to use is fine. If you want to use a straight out standard f, go for it. But our f at x here is our general notation for it, just like, y equals. And this is read as f at x. So the function at the value x. And then we just subsequently replace the x value each time we have a different input into the function. And again, it's replacing the y value of our general equation. So if we had like an equation y equals x, we might have f at x equals x. Do note, you can replace f at x with y. So when we're doing our equations and functions, sometimes we'll switch back and forth between f at x and y. That's perfectly fine. Any f at x can be replaced with a y value. However, not all y values can be replaced with the f at x value. Okay? And that's because there are some functions that there's some relations that aren't functions. Okay, so all functions are a type of relation, but not all relations are a type of function. So moving on here, let's take a look at a couple examples. Which of the following are functions? So remember, our definition of a function is a relation where every x value maps to a single y value. So let's take a look at our first one. 0 maps to 4, 1 maps to 4, 2 maps to 7, 3 maps to 7. 0 and 1 both map to the same y value, but 0 has one line coming off it. It maps to one value. 1 has one value. So in this case here, each x value maps to a single y value. The y values don't have to be different as long as it maps to a single y value, which it does. 0, 1, 2, 3, each have one line coming off them. This is a function. That's a function. In the second case, 0 maps to 4, 1 maps to 6, 2 maps to 5, and 7. Right there, because there's 2 lines coming off the 2, that is not a function. Okay? So 2 lines coming off the 2, not a function. Functions only map to a single value. Graphically, we can see the same kind of thing. So in the first one here, part C, I have a circle. If you take any x value, so say I take the x value of 1 here, it maps to 2 points. It maps to this one here, and it maps to this one here. That's 2 different points that x hits at that 1 value. And actually, we can use what's called the vertical line test. And I can take a vertical line, or ruler, generally, and slide it along. And if that ruler at any point touches 2, which on a circle, other than at the 2 ends here, the tangents, other than that, it's going to touch multiple points, 2 points every time. So this is definitely not a function. Okay? So if you have a graph and you can put a vertical line and it touches more than 1 point, it's not a function. Okay? That would map to 2 points, as we have there. Now in the next case here, we got a parabola. This quadratic function here, it is a function and a quadratic function because if I go across at any given time, any x value only touches the line once. That is a function. All right, a couple more examples. If we got a table of values, and we look at our table here, for every x value, we notice we got negative 1, 2, 4, 6, 8. There's only one set of x values. Each x value has one y value to map to. That's a function then. Now in the last one, we got 0, 1. So 0 maps there, 1 maps there, 2 maps to 8. Then we have 1 again. And 1 also maps to 10. So 1 maps to 10. You can have a 1 as a 6 or a 1 as a 10. And 0 could either be 4 or 12. So really this 0 maps twice. So this is not a function. Okay? So if the x value can only touch one y value, multiple y values can go backwards to an x. Sorry, bring that down. Multiple y values can go backwards to an x, but each x value can only touch one y value. That is our function. Every x value maps to a single y value. And I believe, yeah, that's it for this lesson.